All right, this video is on right triangle trigonometry. So you guys might remember, hopefully, SOHCAHTOA is referring to the ratio of different sides of a right triangle, and this specifically has to be with a right triangle. So that's something I might write in here. It's another thing we call it. So SOHCAHTOA is not a word, it's how we remember the ratios of the different sides. So we start with a right triangle and we always have a given angle. And typically the variable that we use for that is theta. That's Greek and it's T-H-E-T-A, so theta, that's how you pronounce that. And to label the sides in relationship to that theta, we say that the angle, or sorry, the side that is opposite of the angle is called the opposite side. So it's across from that angle. You'll notice it does not touch it. The adjacent side is right next to the angle, it touches it. That's what it means when you're adjacent to something, that you're right next to it. And the hypotenuse is always the very longest side. All right, so longest side across from the angle next to the angle, right? So SOHCAHTOA, you might have sometimes seen it written as S of O over H, so sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Some people write it like that, SOHCAHTOA. So these are the three trig functions that you might have worked with before. Now that we're becoming more advanced in math, we're going to look at three more trig functions. So this is cosecant, and secant, and cotangent. And if you look at the sides, cosecant is just the flipped version of sine. So you take sine and you flip those. Cos is just the flipped version of secant, so you take these ones and you flip them. Tan is just the cotangent is a flipped version of tangent. Another way we have of writing these is this is the same as 1 divided by sine. This is the same as 1 divided by cosine. And this one is the same as 1 divided by tangent. All right, so like I said, SOHCAHTOA only applies to right triangles. Opposite and adjacent are relative to the reference angle. So that's the angle that is drawn in or mentioned in there. There are sine, cosine, and tangent buttons on your calculator. So if we're finding sine of like 50, we're going to type that in our calculator. Your calculator has two different modes for angles, radians and degrees. And the Pythagorean Theorem, if you guys recall from back in the day, that's another thing that applies to right triangles, so we're also going to be using that. And that's a squared plus b squared equals c squared. Okay, so we're going to go ahead and make sure that we can find all of these relationships. I'm going to go ahead and write SOHCAHTOA right here so I can reference it. And they're having us do two different reference angles. So this is using theta as a reference angle. This is using beta, B-E-T-A, beta, as a reference angle. And since that is the case, I'm going to go ahead and draw an identical triangle, because when I do this, I like to write on my triangles. I don't want to have to write and then erase everything, especially since these are notes. I want my notes to be really clear. So first they're talking about theta. So if this is the angle that we're looking at, that means that this one is opposite. This one is next to it, so it's adjacent. And this one up here is the longest side, so it's the hypotenuse. So sine is opposite over hypotenuse, so 5 over 13. Cosine is adjacent over hypotenuse, so that's 12 over 13. Tangent is opposite over adjacent, so opposite is 5, adjacent is 12. And then if we look back at the top, to get the other three, you just flip it, flip it, flip it. So for cosecant, I'm going to take sine and flip it, so that would be 13 over 5. For secant, I'm going to take cos and flip it, so that would be 13 over 12. And for tan, I'm going to flip it, and that would be 12 over 5. Alright, for this one, they're asking us to use beta as our reference angle. So here's my angle right here. That means that now this side is the opposite side. This side would be the adjacent side. And 13 is still the longest side, so it's still the hypotenuse. So if you notice, based on whichever angle we're talking about, the sides have different names. The opposite and the adjacent side can change dependent on the angle. So again, I'm going to use SOHCAHTOA. So sine is opposite over hypotenuse. So opposite over hypotenuse would be 12 over 13. Cos is adjacent over hypotenuse. And so adjacent over hypotenuse is 5 over 13. Tan is going to be opposite over adjacent. So we have 12 over 5. And then to find the other 3, we're just going to take the 3 that we already found and we're going to flip them. So 12 over 13 would become 13 over 12. 5 over 13 would become 13 over 5. And 12 over 5 would become 5 over 12. Alright, for the back page, we're going to go ahead and leave this first one to do in class tomorrow, but we can look at these other examples. So example 3 says, how can I solve for a missing side? So we're going to go ahead and draw a right triangle. And there's our right angle right there, and we have a side of 7 right here. We know that our reference angle is going to be 38 degrees, and our missing side is right there, so I'm going to go ahead and put an X there. So how can I solve for a missing side? The first thing we want to do is label the names of the sides that we do have, so we can figure out which trig function we should be using, which ratio to use. So if that's my angle, here's my opposite side, and this side is touching the angle, so this is the adjacent side. I can see here's my longest side right there, that's the hypotenuse. I'm not going to label it because it doesn't have anything. There's no number there, there's no variable there, so it's not going to help me on this problem. So now if I'm thinking SOHCAHTOA, opposite and adjacent goes with this one, so that means we're doing tan. So tan of our angle equals opposite over adjacent. And now my goal is to solve for x, so I need to undo the divide by 7. So I'm going to multiply by 7 here and multiply by 7 there. And now my x is all alone, so here's my exact answer. Here's my exact answer, and we can also get an approximate answer. And to do that, I'm going to go ahead and type it on my calculator. And we have to be careful when we do this on our calculator to make sure that our calculator is in the degree mode. So if you hit the mode button on your calculator and then look, the default is radians because people in advanced math always use radians. So we have got radians and degrees. We are doing this problem in degrees. So I would go over to degrees until it's blinking there and press enter to make sure that it's in degree mode. All right, and then I can quit to get out of that. So I'm just going to type this in exactly the way it looks. I've got 7, the tan button, all those 3 buttons are right here, so 7 tan of 38. And these are usually going to be decimal answers. And so I'm going to say that that side length x is approximately 5.469. Alright, so we're going to go ahead and do another one where we solve for a missing side because some of these are a little bit trickier to solve for the variable than others. So this time we're going to say that is 5. We're going to have a hypotenuse this time, and our angle is going to be 26 degrees. So I said that was my hypotenuse. This is still my opposite side. So this time I have opposite and hypotenuse, which is sine. So I'm going to say sine of my angle equals opposite over hypotenuse. So the part that's kind of messy on this one is we need to isolate the x, and the x is in the bottom of the fraction. So if you need to do a problem like this, this is pretty simple. Just put the left side over a 1, and then you can cross multiply. So I've got 5 times 1 is 5, and x times sine 26 is just going to be x times sine 26. And then for me to get the x alone, I can go ahead and divide by sine 26. So my exact answer would be x equals 5 over sine 26. And then for my approximate answer, I can do 5 divided by sine of 26. And you can type it in like that, or you can type it in as a fraction. Either way, you're going to get the same answer. So that side length is approximately 11.406. All right, and we're going to do one last problem. We're going to look for solving for a missing angle. So here we're going to have a side of 3 right there and a side of 8 right there. And we're going to solve for this angle theta right up here. And I'll often use theta. I could use an x for a missing angle. It's the same thing. So here again, I'm going to go ahead and label my sides. I know that this side is the opposite down here. So that means that this one is the adjacent. This one is the longest side, and so this is the hypotenuse. So adjacent and hypotenuse is the cosine function. So I'm going to say cos of the angle equals adjacent over hypotenuse. And then since my variable is right here, I need to get rid of cos. That cos needs to go away. And the way that you get rid of cos is you do a cos inverse. Remember, inverses undo each other. So if I have a cos inverse would undo it. Right, so those two are gone. And then that means my exact answer is going to be that the angle equals cos inverse of that fraction 3/8. That's my exact answer. And then for me to plug it in my calculator, to do cos inverse on your calculator, if you look above the cos button, you can see that it says cos inverse, cos -1 in blue. So I'm going to hit second cos, and I'm doing cos inverse of 3/8. And so that angle is 67.976 degrees.